In this video, we have a little practice calculating equivalent capacitance. In a previous video, we derived the equations for equivalent capacitance for capacitors in series using what I call the 1 over equation. And then if you have capacitors in parallel, the equivalent capacitance is what I call the atom up equation. Depending on what we have, we need to use the appropriate equation. Let's determine the equivalent capacitance of these circuits. These capacitors are in parallel with each other. Parallel equation is just the atom up equation. So this one's a real easy one, isn't it? This is just going to be 14 microfarads. 4 plus 7 plus 3. Would they were all that easy. All right, let's try this next one. Now you can see we have some capacitors that are in parallel, some that are in series, and so we need to use the appropriate equation in the appropriate way at the appropriate time to get our final answer. Mentally, what we're going to do here is we're going to take these two capacitors, and if we were to tear those out and just put one capacitor there in their place, we're just pretending now, what would we have for that capacitance? Well, those two are in parallel, so wouldn't that be 10 nanofarads? Again, we're not really going to do that, but we can pretend. All right, if I tore that out and I wanted to put an equivalent 1 capacitor in there, I would put a 10 nanofarad capacitor in there. Now, that imaginary 10 is in series with this 8. So now if we tore out both of those and just put 1 in its place, what would we have for that capacitance? In other words, if we took these two right there, that guy right there, and that guy right there, which are in series, if I just put 1 there, what would it be? In series, we'd have to use the 1 over equation. So we'd go 1 over 8 plus 1 over 10, and then you would add that up and take the reciprocal of that. In effect, you end up with doing that. 1/8 plus 1/10, add them up, and then 1 over that. You probably need a calculator for that, which is fine. That comes out to be 4.44, put the unit on there, nanofarads. So if we tore out this whole top part of this circuit and just put 1 capacitor there, it would be a 4.44 nanofarad capacitor. And that one, although it's imaginary, is in parallel with the 11. If I tore all of this out and just put 1 capacitor in there such that the rest of the circuit didn't know I had done anything, it would be that, 15.44. 11 plus 4.44. Let's try a couple more. How about this one? Again, we need to first pretend that we're going to tear out those two. And when we tear those out, if we did, and put 1 in their place, wouldn't it be a 10 microfarad capacitor? Because those two are in parallel with each other. Now, that imaginary 10, look at the circuit, is in series with this 15. So now we're going to say 1 over 10 plus 1 over 15, because when you do series, you have to use the 1 over equation. You would add those up and then go 1 over that. So in effect, you end up doing that. That comes out to be 6. If I don't want this battery to know that I've done anything, and I want to just put 1 capacitor in there, I tear all these out, I put a 6 microfarad capacitor in there, and I'm done. Last one. What do we have here? We got some batteries over here. These 3 are in parallel with each other, but then those are in series with this one. Let's first take those and combine them all into an imaginary 1, which would be 14 microfarads, because they're in parallel, so you just add them up. Now, that imaginary 14 is in series with this very real 3. When they're in series, we now have to use the 1 over equation. So we're going to go 1 over 14 plus 1 over 3, add them up, and 1 over that. You probably need a calculator for this. I did 2.47. And the unit is going to be microfarads.